Hello guys, let's continue our journey in developing our end language. So we will continue to add the OOP concepts. So in this session we will treat methods, declaration and calls. So let's see this example. We have a declaration class person that have two functions, eat and sleep, without any definition, just for simplicity. And then we have the usual one, instantiation for object, and then we have two calls of methods. The first one is eat and sleep. So let's see the bytecode for method declaration. As you see here, we have op class person, define global person, just usual one for declaring a function, a class. Then I will push to the stack the object class, and then we have op closure for the function eat. And as we did in previous sessions, we treated functions, and function they are simple closures, as you see. So also methods is closures, and the new bytecode here is op method. So this bytecode will the VM when which it treats this bytecode, it will go to the class object and add that closure to this function in its methods hash table, and so on. We will also define the second method, also op closure sleep, the function sleep, and the new bytecode opcode with the name sleep. So as you see, we declare methods with an approach sequentially. We treat the first one and we emit its bytes, and then the second one and emits its byte. So as you see, we have eat and sleep. We emit op closure with object function and the bytecode op method and each, and so on for the other functions. So in the measure of objects, we will have something like this. We have the class object that has the name person and two methods. The first one eat and sleep in the hash table of methods. And for objects, the object will point to the class, and it has also a pointer to the fields. So when we need to call some method, we need to go to its class and search in its hash table and get that object, get that closure, and the VM will do the rest at runtime, and it will call that closure. So let's see the bytecode of call methods. First of all, we need to load to the stack the object person, as you see here, and then we get the property eat. So when we search, we will search that we don't have the property eat in the field, so we will go to methods and we will find eats, and then we will load to the stack the closure eat, and then as you see, op call with a 0 argument because we don't have any argument here. So methods will be treated as a normal function. The only thing that's different is how we declare that with the new bytecode op method, and how we get them from the object with the bytecode op get property. So let's jump to the code and implement that. So guys, we will go to our compiler.c, and in the function compile, just to see the grammar, we have the class declaration with a bunch of functions. So let's go to class declaration, and as you see here we will treat the methods. So what we will do is to loop over until we find a token right brace. If it is not a token right brace, so the closing of the method, or it is not a token end of file, and we will loop over until one of these is treated. So one of these is checked. So let's add the function method. So static void method and what we will do is to consume token identifier and expect a method name in the case of error, and then I will store the constant value of the name of the method identifier constant parser get the previous token, and then I will call the function token with a new type of method, is type method, and okay, I messed up, type method, and then I will emit 2 bytes. The first one is up method and the second one is constant. So the function will do the rest, will emit up closure and so on. This one we've treated that in previous session for functions. So let's add this type in the enumeration method type or function type. So we will add that here, type method, and that's it. So let's go to the chunk.h to add that up method bytecode. Let's go, excuse me, let's go to the debugger.c and debug that bytecode here, case up method, and it's a constant instruction, up method chunk and offset. So let's go to VM and interpret that bytecode, case up method, and we will define the method. So I will read the string, that's the name of the method, and then I will add that. So I will go here and add that function here, static void define method, and we need the name of the method, object string. And so what we need, the first we need the method. So the method is existed on the top of the stack as a closure, and we need also what's the class name. So the class is as class at the position 1 from the stack, pick 1. Why is that? So let's come back here and you will see we did get global person, so the stack until now it has the class person. So we need to add the method and the class person. So after that we have a closure. So at the top of the stack we have the method, and the second element from the top of the stack we have the class object. So then we will call the table set to set the methods in the hash table methods as that name and that value method. And then what we need to do is to pop the method from the stack. So after this instruction, the top of stack, it has only the class object. So why is that? We need to prepare to the second method. So for the second method, the stack needs to has at its top a class object. So we did that pop to pop the method from the stack, so the stack it has only the class object. So that's it. So let's go and create a sample to test that. So we have a sample here, so that has print 18, and we will see what will happen also as its bytecode. So great. So let's clean the project and build it from. Okay, let's go to the VM. Let's see, and I messed up here. Is the address. So make clean, make all. So everything is good. So let's cat and let's see the bytecode. Okay, what we have here. Okay, don't worry about the error, because undefined property we will treat that on the VM and you'll see. So as you see, we have the definition of the, and we have the first method. So let's add a second method, sample. So I will add sleep, and that's it. So as you see, we have the first method and the second method, and for the call we only have, so here there is a call for creating an object, and here we have the call to call the function. So as you see here, we get global, so the person, and we get property it, but the property it is undefined. So why is that? So let's go to the VM and let's go to up-get property. So in the up-get property here, we've treated that we search only in the instance field. We search only here, but here is empty. We need to go up to the class name, to the class object, and search here. Simple. What we need to do is if table get address instance and class and methods, and I pass the name and the value, and I will do that. I will pop it from stack and push the value into the stack, and I will break. So let's rebuild the project. Everything is good, so let's get sample and let's interpret that. So as you see, when we have a call, get property that, and we have a closure on the top of stack, so the call do the rest, and we have load in 18 to the stack and print that, and as you see, it print 18. So far so good. So that's good. We've treated how to call methods. And one more thing I need to mention is that as you see that we have two instruction, 2 bytecodes. So the first one is get property, and then the call with the argument counts. So this is, we have 2 bytecodes to do a call. We need to do some optimization. So the optimization for method calls. So let's see that example. We have 18 with some parameter, and we print that by concatenating 18 with that parameter. So we have the instantiation, and we have the call with some argument bits. So what we need to do is to introduce a new bytecode that simplify or optimize that call. We have 2 bytecodes, we need only one, so we introduce a new bytecode called invoke. So as you see that the invoke bytecode, we need to get the global variable p as a object instance, and we need to load to the stack the argument pizza, and we need to emit 1 byte. So that's sort of optimization. It calls op invoke with two other bytes. The first one is the name of the methods, and the second one is the number of arguments. As here we have the name and argument, but we have 2 bytecodes, so here we will optimize it in 1 bytecode. So in the term of the stack, we have the person instance and the constant. So the top of stack is here, but when the VM run invoke, it should get the closure id and put it at the same place of the person instance, so we can invoke that and read the constant if necessary. So read the parameter if necessary. So let's jump the code and add that bytecode. So we will go to chunk.h and add that bytecode here, up invoke. So let's debug that. Case up invoke, and I will return a invoke instruction with opcode up invoke and chunk and offset. So let's add that function invoke here, static int invoke instruction with const char opcode and the chunk and offset. And what we will do is, let's copy that. We will return offset by 3 because we have the bytecode and 2 other slots. So we have the constant and the only thing we need also, so it's the argument count, excuse me, arg count. So at the chunk code offset +2, and I need to print that here, so I'll add it here, args so arg count here. So that's good. So let's go to our compiler .c. So in the dot function, so else I will do another thing, else if match token left parent so what I need to do is to create the arg count by calling the argument list function, that function. After it gets the argument count, so what I need to do is to emit 2 bytes. The first one is the up invoke with constant, and emit byte the arg count, and that. So let's go to the VM. So and interpret that up invoke bytecode. So what I need to do is to get the object string, the name of the method, by doing read string, and object, and for arg count is the next byte, read byte. So I will call a function called invoke, and I will pass the method plus the argument count, and if something goes wrong I will return the interpret runtime error. and that's it. And I will update the frame because it is a goal. So it frames it vm.frame count -1, and I will break. So let's add that method invoke. So here I will return a boolean value, invoke object swing name and the arg count. So I pick the value object from the stack. So I'll pick it by arg count because I want that instance person, that object. So the top of stack is here, so I need to pick the, let's say that we have, this is the position 3, 4 and 5. So I will do pick from the argument count. So the argument count is 1. So with pick function it will return that one because that is 0, the 0 from the top of stack, and that is the 1 from the top of the stack. So I will do pick arg count, and I will check if is not an instance that I name it receiver. If not, I will raise a runtime error that says only instances have methods, and then I will return false. Otherwise I will make the instance from that receiver instance as instance receiver. So I will, because I need to search, I will make a variable value. So if table get, I will search in the instance fields with that name, and it will return that value. So what I need to do is to update the stack from the -arg count -1. Why is that? Because I need that position. So that position is -arg count -1. So I will put value in it. So I have the closure. The closure is in value, so I put it in that position of object instance. So then I will call our famous function call value based on the value and arg count, and this function, it does the rest. By doing that, it does the rest to run or to execute the closure function. So if the function does not exist in the fields, so I need to invoke that from the class, and I will pass instance class and the name of the method and also the arg count. So let's make that function. So the function will return a boolean, invoke from class, text set a class object, and the name and arg count. So I need to store the closure somewhere else, so I make a variable value, and I will check if doesn't exist that method in the method hash tables with that name, and I put it, if exists I would put change the value. So I will, if not, I will raise an error, a runtime error that says undefined property with that name. Name chars. Now return false. Undefined property with that name, and I will also put the closure in the place of the person instance, in place of the instance with that value, and I will return call value on that value with the arg count. So let's see. So before that, I will run the interpreter with the previous code. So as you see here, we have only get the property and call. I don't want that, I want the invoke. So let's go here and rebuild the project and see the difference. We have, okay, then vm.c, debug.c, invoke instruction. So let's rebuild. Okay, object string, so m.c and string, and also here so let's rebuild that. Okay, vm.c, so everything is good. So let's cut the sample, the same sample, and let's run it. Okay, let's update the sample, and I will do here a variable, a parameter, something. I will concatenate that with that, something, and I will pass pizza. So let's run that. So as you see here, we have the invoke. We will get the global, so the instance object, and we load to the stack the argument pizza, and we have the bytecode op invoke with one argument, and the name of the method is eat. So let's go to 25 instruction, the instruction 25. So as you see here, we load to the stack the closure, and also so we previously we have the instance and the argument pizza. So as you see, we update that position of the instance with the closure, and this is the normal state that we've previously had. So we load and we do the rest for the execution of the function pizza. So in the previous, we only have call. So previously we have this, and after the optimization we have only one instruction invoke that does the 2 bytes instruction in the previous implementation. So I will do one more thing. I will just deactivate these two, and let's rebuild the project. let's update our sample by adding the function sleep, print sleeping. So that's it. I will call also the p dot sleep. So let's run that. Excuse me. So let's as you see, guys, we've implemented, as you see, the output is eating pizza. Okay, that's fun, and let's sleep, and that's the perfect day, eating pizza and get some rest. So guys, we've accomplished something great. We've accomplished class declaration and how to instantiate objects and how to get and set properties of the objects, and also we've add how to call methods or how to invoke method, and we add optimization so the VM can go faster. And what's matter is our language it treats the user program as fast as possible, and that's matter. The time of execution is something that's matter. So we've accomplished, guys, how to call methods, and see you guys in other session, and we will enjoy this journey of developing our Ant language. So see you guys in other sessions.